Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we learned a question number 4 of exercise number 2.7 related with algebraic expression. We solved that type of derivative of that algebraic expression using logarithmic, natural logarithmic functions. In today's video, we are going to start a question number 5 relevant with the same exercise number 2.7 related with a hyperbolic function derivative. So let's move toward a question. It tells that use any suitable rule of differentiation to perform dy by dx for the following function. This is question number 5. There are total 6 part. Part A tells that a function is given y is equal to cos of hyperbolic function into 2x square plus 3 expanded derivative of this function. Remember, derivative of cos of hyperbolic function is always equal to the sine hyperbolic function. So here the derivative will be dy by dx will be actually equal to, here is a cos function, so its derivative is sine hyperbolic. So the derivative will be sine hyperbolic. This function will comes as it is 2x square and plus a 3xo. Now after this we will also take, you know that derivative of the inner function, so it becomes a d by dx of the inner function 2x square plus 3xo. So the derivative will be sine hyperbolic function 2x square plus 3xo, and derivative of this inner function will be 2x square, derivative is 4x according to a generalized power rule, and the derivative of 3x is just 3. So the result will be 4x plus 3 multiply sine hyperbolic function 2x square plus 3. This is actually the required derivative for the part number E. Now move toward part number B. Tells that y is equal to e raised to the power sine hyperbolic function square expanded derivative of this inner function. You know that derivative of e power x is always actually equal to the e power x as it is. So here the derivative will be just like this, dy by dx will be actually e power sine hyperbolic function square according to this formula of the derivative. It becomes e power sine hyperbolic square x. It will come down as it is. Now after this sine h square x is actually the inner function. So we will also take the derivative of this function. So derivative of sine h square xo. So this square can be written as sine hyperbolic function of x whole square. So after this it becomes the e power sine hyperbolic function square xo. After this, according to the generalized power rule, 2 will come to the front and we will subtract 1 in the power, so it becomes sine hxo. And also take the derivative of this inner function sine hxo. So its derivative will be cos hx according to the formula cos of hxo. So the required derivative will be, this is also another formula, 2 into sine a and sine b is actually equal to the cos of 2 times of hxo. So it becomes a cos of 2 times of hxo and multiply e raised to the power sine h square and xo. We have a formula just like 2 sine a and sine b. This is always equal to sine 2 times of a. So here we have used this formula sine 2a. So this is actually not cos of 2hx. This is sine 2hx, sine time of 2 times of hxo. So this is a formula sine time of 2 times of our a is hx in this case. So the required derivative is sine 2 times of hx and e raised to the power sine h square xo. Now move to the third part, part number C. It tells that y is equal to log into cos of h expanded derivative of this inner function, expand derivative of this function. Remember that derivative of log of x is always equal to 1 over x. We already learned in the previous derivatives questions. So the derivative will be dy by dx will be equal to log of xo. Let's suppose this is xo. So the derivative of log of x is always equal to 1 over xo. Our x is cos of hx, so it becomes 1 over cos of hxo. And also take the derivative of this inner function, so d by dx of cos of hxo. So the derivative will be cos of hx, derivative is sine hx. So it becomes a sine time of hyperbolic function algebraic xo divided by cos of hxo. So it will give us the result of sine divided by cos gives us tangent hxo. So the required answer is tangent hxo. Now move to the part number D. Tells that y is equal to secant hyperbolic function into x square plus 1 plus tangent hyperbolic into x square plus 1. Find derivative of this inner function. This is, let's suppose, first function and let's suppose this is second function. We will take the derivative of this function and this function separately. So derivative will be dy by dx will be equal to, here it is a secant hyperbolic function. Remember the derivative of secant hyperbolic function is actually equal to minus secant hx and tangent hx. So here the derivative will be minus secant ho into x is actually x square plus 1 over here, and also tangent hxo. So tangent ho time of our x is x square plus 1. And also take the derivative of this inner function. So derivative of this inner function will be 2xo. And after this plus derivative of tangent ho. Tangent derivative secant square hx. So it becomes a secant square h and x is actually equal to x square and plus 1. and derivative of the inner function will be 2x. Now after this, over here in this and in this function, we are supposed to take out 2x into secant square secant time of hx square plus 1 common. So it becomes 2x and secant h into x square plus 1. So by taking it out common, we are left with a minus time of tangent hyperbolic function into x square and plus 1, because 2x and minus secant hx square plus 1 is always take out common. We are left with tangent hx square plus 1, and here secant 1 secant h is take out common and 2x common. We are left with 1 secant hx square plus 1. So it becomes plus time of secant h into x square plus 1. So this is actually our required derivative for the part number D. Now move to the part number E. Tells that y is equal to cosecant h into x cube plus 1. Find the derivative of this function. Remember, derivative of cosecant hx is minus cosecant hx and cotangent hx. So the derivative will be dy by dx will be minus cosecant hx, so minus cosecant h into, over here the x is x cube plus 1, so we will use x cube plus 1, and cotangent hx, so cotangent h into x is x cube plus 1 over here. This is derivative. Also take derivative of this inner function, so the derivative is just 3x square. So the derivative will be minus time of 3x square into cosecant h into x cube plus 1 into cotangent h into x cube plus 1. So this is the required derivative for the part number E. Now move to the last part number F of question number 5. It tells that x multiply cos of hy will be equal to y into sin hx plus pi. Find the derivative of this inner function. Find the derivative of this function. Here we have two functions. We will use product rule of differentiation. First function x derivative of second function cos of h of y plus of second function cos of h of y and derivative of x. This is the first function, derivative is 1. Will be equal to, here again two functions, so using product rule, so first function y and derivative of sin hx, derivative of sin hx, and plus of sin hx is the second function, and derivative of y will be dy by dx, and plus pi, it is the constant, derivative is just 0. So it becomes x, derivative of cos hy, cos of hx is sin hx, so cos hy will be sin hy, so it becomes sin hy, and derivative of the inner function y will be dy by dx, and plus cos of hy will be equal to y time of derivative of sin hx is cos hx, derivative of sin hx is cos hx, and plus of sin hx and dy by dx. Now shift sin hx dy by dx on the left hand side, and shift this cos hy on the right hand side. So over here it becomes x sin hy dy by dx. Shift sin hx dy by dx to left hand side, it becomes minus time of sin hx and dy by dx will be equal to y time of cos hx, and shift cos of h of y to the right hand side, it becomes minus time of cos of h of y. After this, take out derivative dy by dx common, we are left with x sin hy, and over here minus sin time of hx will be equal to the y cos hx and minus cos of hy. Now divide with x sin hy, so x sin hy minus sin hx, so x sin hy minus sin hx. So this cancel out with each other. Derivative dy by dx is y cos hx minus cos hy divided by x sin hy minus sin hx. This is the required derivative. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC Part 2 Mathematics. Thank you.